the automation and the control system, different types of control systems, and some of the examples and the comparison of these three control systems. So first of all, let's see what do you mean by this automation. So the name itself, automation. So that means auto means it's a self. Matos is a moving. It is a German word which is taken from the German language. So automation means self moving. So why we need this automation? So automation is required to get a quality, precision, and the performance, good performance of a system. Any system, if you consider, we need first of all the quality, the precision of the system, and the performance of the system. So to perform this automation, we need some of the devices like PLCs, digital control systems, personal computers. So now let us see what do you what does this automation include? So this automation, what are the advantages? So automation is basically the conversion of a human made manual operations or the functions into automatic operations. That is what we have seen. So auto means self, matos means moving. So this automation can convert a human made manual operations into automatic operations done by a technical devices or some equipment. Those technical devices or equipment include the PLCs, digital control systems, or the personal computers. So why we need this industrial automation? In these modern days, as the day to day is in progress, there is a high demand for high quality products with economic price in the market. To meet these challenges, the number of industries are implementing new manufacturing techniques with the use of automated devices instead of increasing the human resources. Hence, nowadays, the industrial automation systems are very much needed to meet the demand at the market and also to produce the products at economic price by reducing the various costs and expenses. Now, what are the advantages of this industrial automation? So, with the help of this industrial automation, we can increase the production, we can improve the quality of the products, we can reduce the direct human labor cost and the expenses. At the same time, we can reduce the operation time and working handling time. We can replace the human operators in performing the tasks that involves hard physical and dangerous works. We can also perform the tasks that are beyond human capabilities of the size, weight, or the speed. So, in order to achieve different objectives in various systems with accuracy and economy, we need a system which is called as the control system. So, a control system, before going to this control system, we should know what is a system. So, a system is a combination of different physical quantities or the components. So, in recent years, these control systems have assumed an increasingly important role in the development and the advancement of modern civilization and the technology. Practically, every aspect of our day to day activities is affected by some of control systems. For example, let's take the domestic domain. Automatic control in heating and air conditioning systems, which can regulate the temperature and humidity of the homes and also the buildings for the comfortable living. And these control systems are found in abundance in every sector of the industry, such as the quality control of the manufactured products, automatic assembly line, and in the machine tool control, space technology, and the weapon systems, computer control, and in every robotics and many others. So even such problems like inventory control and social economical systems can be approached from theory of this automatic control. So now let's see, what do you mean by a system? So system is nothing but a collection of matter, parts or the components which are included into a specific boundary. This boundary is the separation of the system with surrounding systems which interfere with its operation. That means before going to learn about a control system, you should know about what is a system. So a system is a collection of parts or the components. Now, coming to the control system, a control system is a combination of elements or subsystems which tends to maintain a quantity or a set of quantities termed output suitably related to another quantity or a set of quantities termed input. That means a control system may be an arrangement of physical components which are related in such a manner direct or to regulate or to command itself or any other system. Or else, that means a control system is an interconnection of various components in a particular configuration to get a desired output or a response. That means if we are applying a proper input, then we need to get our desired value. That means the system controls the variable output to the desired value by applying a proper input or controlling signal to the system input terminals. So we can see that we have a different classification. We have many different classifications of these control systems, among which one is a natural control system which can control the biological and ecological systems, or simply we can say it is the example of our human body. The second classification comes under the man-made control system. These systems are designed or the manufactured by a human being. So for example, let's take a car. To control a car, we need the switches, gears, accelerators, and the braking system. And the third classification is a combinational control system, which include the natural as well as the man-made. That means, for example, for driving a vehicle. So driving a vehicle or a car needs a natural system and also the man-made control system. How we can say that to drive a car, first of all, the person should control his mind. At the same time, based on the input given by the brain, he has to control his vehicle using the accelerator or a switch or a gear or a braking system. Similarly, the example of a switching a bulb. So to switch on a bulb, first of all, the person should receive a signal from the person's brain that the switch is to be turned on to have the light. So, after receiving the signal from the brain, the person has to turn on the switch which is made by a man. So, this is the combinational type of a control system which includes both the natural, that means the biological, and the man-made control system which can include the switches or the gears or the accelerators or the braking system. The next one is the time varying and the time invariant system. So for example, time varying system, that means which doesn't depend on the input or the output. For example, these depends upon only on the mass. That means the weight. For example, the space vehicles. So they depend on the mass of the vehicle. Time invariant systems, which include the electrical systems like the resistors, inductors, capacitors, they depend upon the input or the output. In an electrical system, the input given based on the input, the output will change. Or if the output changes, the input may change. So this is one of the classification of the control system. The next classification comes under the open and the closed loop systems. So open loop system is a dependent system. That means it depends on the input. That means the output of the system is dependent on the input. Whereas a closed loop system is dependent not only on the input but also on the feedback. So in an open loop system, there is no feedback. Whatever the input you give, the output you will get. But the closed loop system, we have a feedback which is which reflects the output of the system. So now let's discuss this classification. Let's see what is an open loop system and the closed loop system. So in an open loop system, we can see here it is a system in which the control action is independent of the system output. That means the output depends only on the input. Okay, so you can see here an open loop system has a controller or a controlling device to control the system process in such a way as to obtain the desired output without considering the actual system output. So this system output is dependent only on the controller. You can see in this block diagram, this controller uses an external power source to have the proper control to the control system process. And we can get some disturbances. So here the disturbances are the environmental changes which we can get. If we have some environmental changes, automatically the process will be disturbed. So hence we can say that this open loop control system is a definite relationship between a desired system output and an actual system output without monitoring the actual system output during the operation of the system. So what are the main features of the system are? The main features are like it has a moderate accuracy and it is sensitive to the surrounding conditions like vibrations, voltages, aging, and so on. But it is very slow to the input command changes, so which makes the system slow and sluggish. Now, on what parameters does this open loop system depends on? So the accuracy of the open loop system depends on the input output relationship, which is designed and calibrated. The performance of the calibration over a long intervals of time is one of the parameter it depends on, and also it will be affected based on the environmental conditions. So, but we have some advantages of the system. Since it doesn't have any it doesn't have any feedback. This open loop system is a very simple in design. It is most economical and it is not expensive. Since we don't have any electronic circuitry, it doesn't include any electronic circuitry. The maintenance of the equipment is very much easy, and also less maintenance is required. And we can say that we can control the system by a human operator with much easy manner. But apart from these advantages, we have a disadvantage like it is an inaccurate and unreliable system because only few variables can be introduced in these systems. And also these systems do not adapt the variations in environmental conditions. Like if any external disturbances occur, obviously, automatically the output will be changing. So, and we cannot get a desired output. And also, we have to control these systems manually. So, we can say that these systems are very slow. And the control adjustment depends on the human judgment and also estimates the it, and it is not that much easy to estimate the variations in the atmospheric or the environmental conditions. So we can say that the open loop system uh, has both the merits as well as the demerits. So, to overcome the demerits of this open loop system, we have a one more control system which is a closed loop control system. So, you can see here a closed loop control system is the system in which the control action is somehow dependent on the system output. So, here it is dependent on the system output. So we can say that the closed loop control system, closed loop control system measures the actual system output and it compares with the input and determines the error which is used for controlling the system output to have a desired value. We can get a desired value. So now these operations can be performed by an output measuring devices. You can see here a feedback which is a output measuring devices which include comparators or a controller or a system plant. So measuring device, here we can see here a measuring device generates the signal proportional to the actual system output. And this signal is compared with the reference input and an error is generated. That error is amplified by an amplifier which produces an actuating signal. Means that is actuating signal is which is nothing but is a error signal which is modified one. So the actuating system operates the controller, thereby applying a control signal to the system plant, which changes the control system output to the desired value. So we can see here the characteristics of this control system, which is a closed loop, has a high accuracy, fast response to the input signals, and relatively independent to the operating conditions. So the accuracy of a control system, this closed loop control system, depends on the output measuring device accuracy, comparing device accuracy, sensitive and control system accuracy. So now let's see the sequence of operation of a closed loop control system. So here you can observe the closed loop sequence of operations in a system. So where a measurement of output is compared with the reference input and calculation of error is taking place, and then the error, after the calculation of error, the actuation of the controller is there and controlling the system process. So this is the entire sequence of operation of a control system. So we have seen what is an output and what is an open loop and what is a closed loop. So closed loop has a high accuracy, fast response, and it is flexible. But apart from those, it also has some demerits, which is like it is cost, that means more expensive than simple made operating systems, which is an open loop. Maintenance is difficult as it involves complicated electronics, means we have a feedback. So the maintenance is requires more maintenance, and in the same way, installation and adjustment is very complicated. And if any fault occurs in the instrument, that leads to a faulty error signal. So that means It may occur due to open circuit or short circuit in inner circuitry. So, in such cases, the fault location becomes difficult and it takes more time for the maintenance. And also, this maintenance, coming to the maintenance, the persons who have trained in that related field only can and do the maintenance of this control, this closed loop control system. Now let's see some examples of open loop and the closed loop control systems. So first let's see the comparison. See here the open loop and the closed loop. One of the best example is the traffic flow control system. So a traffic flow control system used on the roads to regulate the flow of the traffic, which you can see here in a block diagram. So in this, the traffic moves when green or yellow lamp glows, while the traffic stops moving when the red lamp glows. That is a general scenario which we can see every day on the roads. The traffic on the road becomes mobile or stationary depending upon the duration and the sequence of the lamp glow. The duration sequence is controlled by a relay which are operated from an external power source. So these relays are adjusted for particular values of time duration and a sequence for the desired traffic flow through a calibrated dial. The settings start glowing the lamps in a particular sequence with a fixed time interval, thereby making traffic stationary or moving. So, the sequence and time durations are not influenced by the actual flow of the traffic. That means the green lamp can neither be increased when traffic light when we have a more traffic on the road, or neither or nor the it can be reduced when there is no traffic on the road. So a desired traffic flow control is not affected by the actual traffic which is on the road. That means input to the system is independent of the output. For example, let's take if we have a traffic jam on the road due to an accident on the road, so this will not change the glowing sequence of the time of the green light or the red light. So hence, this system is an open loop control system where we cannot change the sequence of the lights. It depends only on the value we have fixed. So now let's move to the other part, that is the closed loop. Let's see how a closed loop works in the same scenario. So here you can see in the block diagram the closed loop system which uses the control. Here using a closed loop path, we are controlling the traffic flow. In this, you can observe the flow of the traffic is measured by a traffic measuring device, which is like, for example, we can keep like a electronic photo tube, which generates a signal proportional to the traffic moving on the road. So this signal is compared with the desired traffic flow in the comparator and the error is produced. This error then changes the lamp glow time and sequence through the relays so as to bring the actual traffic flow same as the desired flow. So, for example, the jamming on the road will influence the system input through a traffic measuring device, because at every instant the information regarding the flow of the traffic is sent to the input through the feedback path. Hence, we can say that this system, that is a closed loop system, is also sensitive to the output disturbances. But a system is a closed loop system as the input is influenced by the output through the feedback path. Here we can control the sequence of the lights based on the traffic on the roads. So one of the example is this. The other example, if we go for, let's take for the example of a biological system. So here, a biological system which includes that means which will be which includes like the man walking. Let us take an example: the man walking on a prescribed path with the eyes closed. With the eyes closed, if you imagine, how can a man walk on a prescribed path? So if you see here, when a man is asked to move along a prescribed path, keeping his eyes closed, so after showing him the path, before only we have shown the path, but we have asked the person to close his eyes and move in a prescribed path. So the major components of the systems now are the eyes, brain, muscles, legs, and feet. Now the brain senses the prescribed path through the eyes when the eyes are not bound. That means the eyes are not closed. That means when the eyes are open. Now, depending upon the sensor, the muscle system is to move the legs and the feet in a particular direction. When the eyes are closed, the man is asked to move on a prescribed path. Due to the movement of the feet, the man starts walking, generating the actual path of the movement. As the eyes are closed, the actual path movement cannot be seen and sensed by the brain. Hence, the actual movement path has no effect on the prescribed path, thereby making input independent of output, and the system becomes an open loop system. That means in this open loop system, a man who has closed his eyes cannot cannot know in which path he is moving, in which way he is moving. So, to move in a prescribed path, we have to give a feedback. Now, let's see the same example with the closed loop. So, if a human or a man is walking in a prescribed path, which can when the eyes are open, so the path of an actual movement is compared with the prescribed path in the eyes, and error is detected. The error is transmitted to the brain, which senses the error and operates the muscle system in such a way such that the legs and the feet move on the prescribed path. Thus, every instant the system output is compared with the input through the eyes, because now the eyes are open. Now the eyes are like a feedback path. In the previous case, when the eyes are closed, we cannot know what the prescribed path is. So now, since the eyes are open, we can know the path which the man is moving is a prescribed path or not. So hence, every instant of time, we can say the system output is compared with the input. The desired movement, that means through the eyes, thereby creating a feedback path between the output and the input. Here, the disturbances or the changes in the output influence the input and thus the controlling process. Now let's see the comparison between an open loop and a closed loop system. So we can see the first comparison. In an open loop control system, the control action is independent of the output, whereas in a closed loop system, the feedback control system, the control action is some way or the other, it is dependent upon the output. And these open loop systems are very simple to design, whereas since feedback is required, it is a complexity. It is very complex. Since a complex circuitry is there in a closed loop system, it is more economical, or a cost is more in of a closed loop system. Since the feedback is absent in an open loop system, the open loop system is more stable when compared to a closed loop system, which includes a feedback. So, hence the system is stable. We can say that the accuracy can be moderate in an open loop system, and the closed loop system has a high accuracy. So, as discussed, for the examples, we can some more examples like automatic toaster system uh, can also be considered. So, with this, we can say that I can conclude that uh, the Closed loop system, the closed loop systems and the when we compare the open loop and the closed loop systems, we can say that a closed loop system is much preferable than an open loop system. So thank you.